Good afternoon, everyone. Good afternoon. All right, good afternoon. Health and Human Sciences researchers are taking giant leaps to improve lives in Indiana and around the globe. Thank you for joining us for the third in a series of HHS Learn and Lunch presentations during Purdue's 150th anniversary year-long celebration. And a special welcome to our online audience. The College of Health and Human Sciences is grateful for the HHS Alumni Board's contribution to this program. I am pleased to introduce today's presenter. A.J. Schwichtenberg is an interdisciplinary researcher with appointments in human development and family studies, psychological sciences, and speech-language and hearing sciences. She currently serves as co-director of the Purdue Autism Cluster. Dr. Schwichtenberg's research evaluates the intersections of autism, family, treatment, and sleep. In this Learn and Lunch presentation, she will highlight some recent studies for her developmental studies laboratory, which assesses roles of sleep during early behavioral treatment, sleep in families raising children with ASD, and sleep's contributions to autism risks. We hope you enjoy this presentation.
I am so excited that so many of you are interested in sleep and autism. This is just like, I'd like to think you came for it, but I think the lunch might have had something to do with it. So I'm glad you can get filled up, and I'm glad you're here to learn a bit about sleep and autism. I want to give a quick disclaimer. This is not a talk about treatment and how to help treat sleep problems in your young children or your children who have autism. That is a different talk. We can talk about that another time. Really, today's talk is going to be about characterizing sleep in autism and what are the developmental consequences of it, and what does that mean within the family context, okay? I also want to highlight that this is some of the autism work that's going on here at Purdue, but it is just a small sliver of some of the work. We have an amazing group of individuals associated with the Purdue Autism Cluster, and I wanted to take this chance both here and online to be able to give a plug to the cluster. If you just Google autism and Purdue, the page will come up and you can see things about the research of all of these amazing people, okay? So I also want to give a plug that we are doing a funding initiative. If you go to the webpage, you can learn all about it. We're super excited to be a part of the giant leaps in the 150 years of Purdue, okay? All right, why study sleep? There are a lot of different things you can study. And quite frankly, for me, making sleep one of the focal areas of my research was a bit random. But the more I learned about it, the more I studied the different ways in which sleep influences the lives of not only children, but of families. It influences social emotional regulation, learning capacity, attention, behavioral problems, immune function, obesity risk. It really can have a very profound influence on development. I often equate sleep with exercise and diet, right? It's not necessarily what you do on one day, what you eat at that 4th of July picnic, but it is your pattern over time that really matters. Now, we used to think about sleep as a very passive process, that this is what your body did when it was not doing anything else. The field of sleep medicine and sleep research has come a long way, and we now understand that sleep is actually a very, very active process, particularly in the brain. And it requires a lot of things to be successful, right? It requires that you have attention dampening, that you can physically relax, that you can reduce your arousal level. How many of you have kind of watched a TV show and then it's one of those amazing dramas and you're like, and now go to bed? You have to like bring yourself back down. It requires very distinct physiological shifts, and it requires the ability to have cycling within the brain. I'm not going to go too far into neuroscience on this talk, but ultimately know that at its core, sleep is a neurological process. Okay. And in that, when we think about sleep, when we think about the phases of sleep, those are neurologically defined, okay? This is what's called a hypnogram. And it talks about, everyone's heard of the stages of sleep, right? You start off in this very light sleep, and then you pretty quickly transition into deep, or what is referred to as slow wave sleep. And then you'll transition back out, and then back down, out and back down. And you cycle through this roughly 4 times a night. This period here of slow wave sleep for most individuals is between 45 and 90 minutes. And then each time you go down, it gets successfully shorter as you go on throughout the night. Now, slow wave sleep has been associated with optimal development, right? When we talk about trying to promote optimal development in individuals, we often are talking about how to increase a couple different kinds of sleep, and one of them being this slow wave sleep. Now, in order to be able to capture these wavelengths, you have to have EEG data. You have to have a cap on your head. But I want to show you something here. There's also something that happens physically as you go through these stages of sleep. And for various reasons that I won't get into here, our body's actually paralyzed for portions of sleep. When you go into slow wave sleep, you have no activity. Then you come back out into what's called active sleep, or stage 1 and 2. And then you're paralyzed again for REM sleep. And then you go from 1 and 2 as you're transitioning down. And then we have these bouts of no activity. So what we can kind of see here, right, is you're active as you're transitioning down. This is your active sleep. Then you have a period of quiet sleep. Then you have a little bit of active sleep. You have quiet sleep during REM. Then another period of quiet sleep, and so on and so forth. So by indexing activity, we can get a rough estimate of the cyclicity of these cycles, okay? Now, the gold standard in sleep assessment is something called polysomnography, but I will tell you it has a practical problem, okay? I study sleep in a lot of children, and I want to assess what their sleep typically looks like. And I can't go into a home or bring children into a laboratory, put 8 sensors on their head, 1 on their face, 1 on their chin, 1 up their nose, 1 on their finger, 1 across their chest, and then say, now go to sleep, right? Now, I don't want to completely diss polysomnography. It is very good at what it does. It was designed to capture pathology. It was designed to capture if maybe you've had a parasomnia or if you had nighttime seizures. It is the only way to capture some of those things. But as a developmentalist and as a scientist, we need other methods. And so this has been solved in a couple of different ways. Some researchers and some clinicians have gone to home-based polysomnography. They've just minimized the number of sensors that have to go on an individual's body, and they do it in the home rather than in the lab. And so that's been effective. They also use something called actigraphy. So many of you are wearing smartwatches or you're carrying your smartphones, and something that all of those have in common is they have 3-way accelerometers in them. Those accelerometers can be used to translate the amount of movement that you have into activity. That's exactly what actigraphy is, except we're using those activity indices to indicate, remember how you could use activity to roughly estimate those cycles of sleep? That's what actigraphy is doing. And then there is a method called videosomnography. And this is something that our lab has actually done a lot of. I'm a big proponent of the less that we can intervene, the better. And this idea of like, I just put a camera in place and it can give us indices of sleep is delightful. And I won't talk about it here today, but I'll just wet your whistle for a little bit so you'll want a little bit more later. But we've been able to record sleep in young children and extract things like respiration and heart rate just from the video. And it's been really, really exciting to watch Purdue's powerhouse in computer and electrical engineering and our kind of data science approach come together. And this work is in collaboration with Dr. Edward Delp, okay? And then there's also parent report, and then as children get older, self-report. So this is actigraphy from 2 different kids. If you look at the top 4, that's 1 child, and if you look at the bottom 4, it's another child. And what you can see here is this is how active this child is during the day. Here's when they watch a TV show, a little active again. This actually reflects a removal, so the sensor was removed. They're active all day long. The blue area here represents when they're put into bed for the night. So we said, parents, tell us when you intend for them to go to bed, right? When you put them into bed. And then we can watch them transition to sleep at night. And then you can actually see, remember those cycles we were talking about previously? You can actually see how children are cycling throughout the night. Now, what you can't tell from this is here we have roughly a 30-minute period of activity. Here we have a roughly 20-minute period of activity. Sometimes we wake up, we roll over, we look at the alarm clock. It takes us a little bit to kind of transition back to sleep. Sometimes as children, when that happens, they signal for their parents, and it becomes an awakening that parents are opportunely aware of because it's woken them up in the middle of the night. Now, one of these is a parent-reported awakening and one of them is not. But you can't look at the activity data and discern that. And so for that reason, actigraphy best practices always include a closely aligned parent sleep log so we can interpret what's happened here. So this one would be categorized as an arousal and this one as a true awakening because it required parental intervention. Okay? All right, so when we go to pull out sleep information, in the whole 24-hour period, we can get 24 hours sleep, kind of how much we expect them to be able to sleep in that 24-hour period. We get an indication of their naps. We get an indication of how much is happening at night, but we can really only get this with the help of parents, okay? All right, let's keep going. You guys are gonna leave like sleep educated here. So when we talk about sleep, the two-process model is the most common model used by researchers and by clinicians. I will tell you that there have been advances in this model that don't have a ton of research behind them yet, so check back in 2 years and I'll have shown you the adjusted model. But for right now, we have two processes that are really driving our biological processes in sleep, and we'll talk about contextual processes in a moment. We have the circadian drive, which is a train to day-night cycles. And so the exposure that we have to light during the day and the lack of exposure to light at night. And then we have the homeostatic drive, which is really the longer you are awake, the higher your propensity for sleep. And so these two systems work not completely independently, but they have their own driving forces. So you wake up in the morning, you are exposed to light. This ultimately is your driving force to be awake. This driving force to be awake builds up until about 2 or 3 o'clock in the afternoon. And then at that point, it wanes and starts to come down, preparing for sleep. This is why in many cultures around the world and why many of us at 2 or 3 in the afternoon are like, I either need a cup of tea or a nap, because we can actually feel that drive decreasing. And then the longer that individuals are awake, the greater their need for sleep, okay? In children, though, it looks a little different. They still have that same circadian process. And I will tell you, this circadian process is really sensitive to exposure of light at night. So if you are exposing yourself to very bright lights at 10 p.m. or 11 p.m., it does have the potential to influence the system quite profoundly, okay? In young children, the homeostatic drive, any of you who have visited an infant or a toddler, you will know that they get tired faster, right? And so their homeostatic drive has a greater slope or greater increase. They take naps, it comes back down, and then it increases and then goes back down. So children will function at a much higher propensity of sleep debt, if you will, or sleep need than adults will. So let's go back to these same two children. So we've got this child up here and this child down here, and we can see their circadian patterns, right? You can see activity during the day, less at night. We've got a rough estimate there. But we've got that homeostatic drive too. Now the homeostatic drive for these two kids looks very different, right? We have the one kid who is allowed to recuperate in the middle of the day with a nap and then builds back up and goes to sleep. And then we have this other child who is transitioning out of naps, but just has this great build during the day and then transitions at night. And if we look at kind of regularity of their cycle and we say, okay, this is the homeostatic drive for this given child, it's pretty consistent. When we look at this given child, we can see that there's a lot more variability going on with their day-to-day sleep patterns. So what we attempted to do statistically was to model both circadian and homeostatic patterns in order to get what would be considered the prototypical, or what you would expect the combined influence of these two powers to be. And so we end up with a model that looks similar to this, and we look at it across the day. And we say, how closely does this child's sleep pattern, right? We're trying to capture patterns, not just one tiny bit of sleep information. And how does that relate to development? And we actually found in one of our at-risk samples, this is actually children born preterm, that how closely you aligned with that prototypical pattern related to preschool age health risks, developmental concerns, attention concerns, that it really was developmentally consequential. Now keep in mind, the sleep data that we looked at for these infants was 3 years before we looked at outcomes. But it's really representing patterns of behavior. And the take-home point was that sleep is developmentally consequential. Like, it has ramifications for these children, and it can be even more so if they're developing at risk. And that's why we're going to switch over to talk about children with autism. But I also want to highlight, like, when you go to the pediatrician, they'll say, what time does Simon go to bed? What time does Simon wake up? We'll give you a rough estimate of how many hours of sleep that he gets. But really, sleep is far more complex than that, and being able to understand the influence of sleep takes more than just number of hours of sleep, okay? All right, what you all came here for, sleep and autism. You have that lovely backdrop. Now let's talk about where it is that children with autism may have difficulty in those processes. And the answer is all of the above, right? Children's sleep problems in children who have autism are just as diverse as the children themselves. And so for me to stand up here and say this is the autism sleep problem would be inaccurate. These are some of the more common ones that tend to be highlighted, but that's not necessarily unique to autism. These are more common sleep problems for a lot of different children. So sleep onset difficulties, taking more than 20 minutes to transition to sleep. Insomnia, sleeping less than recommended by the American Academy of Pediatrics for their given age. Circadian shift difficulties. Remember how we talked about we want your circadian cycle to be aligned with the daylight cycles outside? But for many children with autism, that system tends to shift and kind of constantly be in a state of shift, and so parents find themselves kind of constantly trying to bring their child's circadian system back. And then rhythmic movement disorders, and this is a given condition in sleep where your legs feel like itchy and you kind of feel like you have to, and many of us have experienced this when you get overtired, right? You get overly tired and you'll be like, oh, my legs are just itchy. Kind of amplify that to the point where it doesn't allow you to sleep, right? Okay, let's talk about what we know and what we don't know, okay? Sleep problems are common. They're common in the general population, period. This is not something that is entirely unique to individuals with autism. And this here is in the general population. Now, estimates of how many children have sleep problems end up right around 25%, but as many as estimates as high as 50% of children under the age of 3 will experience a sleep problem, okay? And we see gradually over development a decrease in the number of sleep problems. These are primarily parent-report sleep problems. And then we see a bump up in adolescence. I'm not going to go into adolescence in too deep, but for those of you in the audience who have adolescents, the reason we see that little uptick is actually a clash between biological forces and contextual forces. And what we see in adolescents as they kind of mature through their Tanner stages is they have this natural circadian shift to want to stay up later and sleep in longer. But what happens in our society, and Indiana is no exception to this, that they are actually asked to get up earlier, right? Because they have the earlier school start times. And so we've kind of created this perfect storm for insomnia and low levels of sleep in adolescence. And so this bump here I think of as the contextual bump. But now the blue line represents children with autism. I want to highlight two things for you. One, it's double or more than what we see in the general population. But look at the variability there. Look at how variable sleep estimates are. As high as 80% of children with autism are going to experience problems, and as low as 25%, which is right in line with the typical group. The answer, variability, you'll hear come up again and again. It's a real theme when it comes to sleep and autism. So the data I'm going to present for you here is actually some data that I collected with Dr. Thomas Anders at the University of California, Davis. And we looked at preschool-age children with autism. If we go back to this little chart, being able to inform this line of information, going back about 5 years ago, we really didn't know much about that particular age range. And so this is one of the studies that contributed to that. So we had 68 children with autism. We had children who had developmental disabilities that were not autism. These included things like Down syndrome or Dup15q. And then we had typically developing children. And we assessed their sleep using actigraphy and diary, did some developmental assessments, looked at their daytime sleepiness. And functionally what we found is, indeed, that children with autism slept less. And now this is behaviorally defined. This is from the actigraph. This isn't parents saying my child slept less. This is us observing it and seeing that it happens. But when we actually looked at nighttime sleep, it wasn't the children with autism who were sleeping less at night and who were waking more. It was actually the children with developmental disabilities. And we found that really variability was a function of having a neurodevelopmental disability. It wasn't a function of specifically having autism. But now you have to ask yourself, well, what is driving this then? Like, how can they have lower levels of sleep if they're not sleeping less at night and they're not having more awakenings? And really, in the preschool period, what we found is it was daytime sleep. That it was that the children with autism transitioned out of naps far earlier than their peers. And this resulted in missing about an hour and a half to 2 hours of sleep because they weren't compensating for it at night. Now, this is not the first time in this given age range, in that preschool period, that daytime sleep was influential. In that preterm sample, we found it there as well. In another research group that was looking at children who were developing at high socioeconomic risks, it was a very similar pattern. So I think oftentimes for parents, nighttime sleep is really like the thing that keeps them awake, but I would encourage you to pay attention to daytime sleep as well. Okay, all right, let's talk a little bit about how sleep can influence development, particularly in children with autism. And I'm going to talk about young children with autism because that tends to be where my research is focused. So this project I'm going to talk to you about was led by Emily Abel. She's a graduate student in the lab. This was actually her master's thesis. I'm very proud of it, so I want to tell you about it. So we have a long history of parents reporting we have elevated rates of sleep problems in our kids. My child just won't sleep. And then these same parents report they have problems with attention, and they have problems with aggression, and they have problems with emotion regulation. And so we have one reporter reporting both things. There's an inherent problem in that, right? That if you take, for example, a mom who is stressed for whatever reason, she's working 3 jobs, she's a child who has extreme behaviors, any reason, you may find an individual who it's sometimes referred to as the negative halo effect, that they'll find problems here and they'll find problems here. And so then there was a little bit of research that looked at, well, let's look at parent reports of problems and what the actual behavior is. And then there was a little bit of research that looked at, let's look at the actual sleep behavior and we'll just ask parents to report the problems. But very, very rarely do we actually get objective measures of sleep and objective measures of behavior to really look at this relationship. And that is one of the contributions of Emily's thesis. And where is it that we think sleep would be developmentally consequential for children with autism? During treatment, right? Young children with autism, for many of them, spend large chunks of their time during the day in treatment. Particularly in Indiana. Indiana is a mandate state, which means if your child has a medical diagnosis of autism and your parent's employer has a certain insurance program, it is possible for insurance to pay for center-based ABA care. And so we have a lot of center-based ABA care here in Indiana. And so that's where she went to do her research. She went into these centers and said, I want to look at things that potentially are getting in the way of progress. I want to look at things that may be influencing your child's ability to be able to learn in that context. And so she had therapists wear these little buzzers. How she got them to agree to this is amazing to me. Wear these little buzzers, and every 5 minutes it would buzz, and they would have to say, did any of these problematic behaviors occur? Self-injurious behavior, aggression, non-compliance, negative affect expressions, and I forget what the 5th one was. But ultimately, these were all behaviors that would impact or be disruptive to their learning process. So every 5 minutes, they would say this happened or didn't happen for the entire treatment day, over the entire treatment week. So we have very detailed behavioral data on what we called challenging behaviors within the treatment context. And those same kids wore actographs home, and their parents recorded details about their sleep. And so now we have behavioral information about their sleep and very detailed information about their behavior. And what she looked at it in 2 different ways. One was, let's just look at patterns over time. Remember I talked about it's like diet, right? Look at that pattern over time and then how it influences their overall pattern of challenging behaviors. And she said, well, think about the night that you don't get any sleep, and then the next day, the world is just a harder place to be in, right? Like, it makes sense that this may not be a pattern over time, that there is this temporal order between bad sleep and high levels of behavior problems. That any parents in the room who have children with autism would be like, psh, I can endorse that, right? I have seen that firsthand. We said, all right, let's put some data behind it. And indeed, what she found was that your overall pattern of sleep, if you had an overall pattern of sleep dysregulation, it was associated with higher levels of these challenging behaviors, just in general. She did not find any support for this had a bad day and the next day they're super elevated in the context of treatment. There was variability in children from day to day, but it wasn't systematic. It wasn't one of those, and we even looked at, well, maybe it's like you have a bad night's sleep and then 2 days later. It wasn't the case. It really was looking at it as an overall pattern and how it is that you can influence that pattern and not just 1 or 2 nights of behavior. Okay, let's take this back to the family, because really when we're talking about sleep and autism, it's a family phenomenon. And previous studies have documented that parents of children with autism have elevated rates of sleep problems themselves, that they endorse that they have more difficulty with sleep. And our group was one of the first to document that not only do we see elevated rates of sleep problems in the children with autism, but also in their siblings. We have elevated rates. And so I was left going, okay, parents have difficulty sleeping, children have difficulty sleeping, their siblings who don't have autism have difficulty sleeping. It feels like a familial or a potential genetic risk marker here, or is this all context? And so that led us to our next question, which does a familial risk for autism really confer a risk for sleep problems? That really this is kind of the same risk pathway? So before I go into the details of this given project, I have to take you a step back. I have to introduce you to a particular study paradigm. So this is a very common paradigm in the field of autism. It builds on a specific premise that clinicians had noticed over time. And what they noticed is that a family would come in with a child with autism, and then they'd watch that child grow for 2 or 3 years. The family would have another child, and then they'd say, that child developed autism too. Like, why are we seeing autism kind of in a familial pattern? And so researchers said, let's capitalize on that. And how we're going to capitalize on that is that we're going to take a family that's raising a child with autism, and we know that autism is not typically diagnosed until 3 or 4 years of age. But we're going to follow this child before that. We're going to look for some of the earliest signs of autism. We're going to be able to provide intervention potentially for these kids before they receive a diagnosis. That we really want to know what is it that's kind of putting this child at elevated risk. But in order to know the risk for this child, we have to follow a cohort of what is often termed in the field a low-risk group. So this is your child who qualified you to enroll, and then we're going to follow this child. And now we follow these children at 6, 9, 12, 15, 18, 24, 30, 36 months. We are interested in their development. We want to know their developmental trajectories, because what studies like this have shown us, and Purdue is one of 26 sites around the world who follows this paradigm to try to really inform these big questions. And we had a very big paper about 5 years ago that said, what is the likelihood that this child will develop autism? That's what families want to know. And so the answer is roughly 20%. Roughly 20% of these children will go on to develop autism, compared to roughly 2%, 1 to 2% of these children, okay? So we know that these children are at elevated risk, but not only for autism, and I'll talk a little bit more about that. I want to add this caveat. I talk about high risk and low risk group, and I in no way want this to be data to in some way encourage families not to have siblings or not to have a child with autism and not continue. Honestly, I think siblings is one of the most amazing gifts you can give their child. It is the only person who will be with your child through their life course. And it is one of those pieces. We're going to talk about risk here, but really the majority of these siblings go on to have what most researchers would call typical development. So I'm going to focus on risk here, but I don't want families to focus on the fact like, oh, should I have another kid? And I have to tell you, so we answered that great big question, and now families have come back. And now, instead of saying, what's the likelihood that this child's going to have autism? Because this child's grown up. They're like, what's the odds if this child has a child that this child's going to have autism? And I just came from a meeting in Chicago that was super invigorated, and we are attacking that question. So, to be continued, okay? All right. So I alluded to the fact that children in the high-risk group have other difficulties outside of autism, right? This is that high-risk group, and here are the children who went on to develop autism. But we have another large percentage, right? Another roughly 30% that go on to have other developmental concerns. And sometimes these concerns fall into the category that is sometimes referred to as the broader autism phenotype, or just like little quirks. And we all have them. It doesn't mean that it's gonna have like a negative impact on your life. But it's one of those things you may benefit from additional support early on. And so we were interested not only in the children who went on to develop autism, but also these siblings who had developmental concerns. And that's where we assessed sleep problems, was in those high-risk children. And what we found was indeed parents reported that they had more sleep problems than the children in the low-risk group. But more interestingly, when we looked at the influence that it had on their behavior, we found that it had a far greater influence on their behavior. But now keep in mind, this is behavior reported by parents. But if you were a high-risk infant and you had sleep problems, the likelihood that you would also present with aggression behavior or aggression difficulties was quite high. And so this idea of not only are we finding elevated rates, but we're finding really high influence from it. And so we wanted to keep going with that. And so we said, okay, let's look at the sleep of these siblings. Now, there's something to know, right? In developmental disabilities, period, sleep problems are more common. It is not something that is unique to autism. So we wanted to be very careful and say, is it a function of risk, right? That you're in a family that's raising a child with autism? Or is it a function of that your child is one of those children who have developmental concerns? And because we kind of peeled off the children who had autism, because we know that that's very well documented, that they will have sleep problems. But we were really focusing in on those other siblings. And so when we look at just high risk, low risk, we actually didn't find that parents were reporting, based on parent report measures here, that their children had more difficulties in these given scales. And actually, we didn't find that parents were reporting more sleep problems in themselves. It really was not just because you have a child with autism that everyone in your household has sleep problems. When we looked at it based on if you had a developmental concern, right? This had nothing to do with whether you were raising one child with autism or not. We found that indeed we found more sleep problems when your child had a developmental concern. But really, we didn't find a difference in parents. So just because you had a child with a developmental concern didn't mean that you as a parent endorsed more sleep problems. But if you had a child with a developmental concern who had a sleep problem, either you reported or was behaviorally defined, then you reported that your sleep was more dysregulated. And I feel like this is one of those research findings that's duh, right? That everyone's like, why is that so profound? So the concept that just because you have a child with a developmental disability doesn't mean in some way that it automatically implicates your sleep and your biology. But if you have a child who wakes up at 3 a.m. and says like, hello, the day has started, welcome, it's going to influence your sleep as well. And so you're more likely to endorse those sleep problems. Now, we came at this kind of familial sleep problem from another angle as well, and that's looking at genetics. Right? What is familial risk? It really is shared genetics. It's a shared polygenetic load on given factors. And so this was a paper in another project with Emily, where we took some publicly available databases that had genes that were known to be elevated risk markers for autism. And these datasets are publicly available. Anyone can access them. And so we took these 117 genes, and then we said, well, let's compare this to a database of genes that put you at elevated risk for sleep dysregulation. And we went out there and we said it doesn't exist. We said there's these wonderful databases for autism and all of these different disorders, schizophrenia and bipolar. It doesn't exist for sleep disorders. So we created one. So we used very strict criteria to hand curate a sleep gene database. And we found 154 genes that were associated with elevated risk for sleep problems. And then we said, all right, where's the overlap? Where do we see elevated risk for autism and elevated risk for sleep problems? And we identified 16 genes that fit in that category. Now, anybody who's a statistician in the audience will be like, well, if you look for overlap, just by chance, you're going to have some. We absolutely agree. And so we were like, is the overlap we're seeing above what we would expect to see by chance? And indeed, just by chance, we would expect to have seen 2 genes overlap. So 16 genes, for those of you who are into analytics, was significant in a big way. So we did find substantial overlap between these two. But genes can inform more than just that there was overlap. What kinds of genes were we talking about? What was it that they related to? And the ones that made the most sense to us were actually circadian entrainment and melatonin synthesis, right? Melatonin is a part of that circadian process. And we identified that there were 3 genes in particular that were very clearly aligned with autism, or very clearly aligned with sleep, but tend to be more common in children with autism than in the general population. And interestingly enough, several of what are sometimes referred to as big hit mutations also showed up. So MECP2 is the mutation for Rett syndrome, and UBE3A is for Angelman syndrome. And so we were like, well, there's a lot going on here than just sleep as well. But we didn't want to stop there. We said, okay, we have all of these genes, and we want to identify what are the pathways that they're influencing. And now, let me tell you, in autism research, if you look at any neurotransmitter, almost, there are studies to report that there are dysregulation in that system, right? So if you look at dopamine, serotonin, glutamate, GABA systems, there are studies out there that will tell you there's an imbalance in those systems. We didn't find genetic risk associated with those particular ones. The only one that we found support for was the dopamine system, and that it was implicated in both. Now, we subjected this data to what is called enriched path analysis. And so that particular piece says, are these genes converging on a given neurological pathway? I'm losing some of you, I know. I see wrinkled foreheads. Don't worry, we'll come back. Is there a given pathway that these genes converge on? And indeed, it was the dopamine system. But then there was also chemical synapses, general neuronal systems, Rett syndrome, and sudden infant death syndrome. Now, these 3 systems here, they're really global. They're really big. I don't want to overinterpret this idea of sleep as a neurological process, autism as a neurological developmental disability, and we find that there are neurological overlap between those two. I don't think this is anything to take home to the bank, but it does give us target genes to pay attention to when we're looking at the comorbidity of these 2 disorders, okay? All right, let's go back to where we don't have any data, right? We have very little data looking at what is it in infancy and prior to diagnosis that sleep looks like in children who go on to develop autism or children who go on to have developmental concerns. And that is where the high risks, or the infant sibling study here at Purdue is really focused on. All of the 26 sites have kind of a given area that they plan to enrich the field, and that's our area that we're planning to do that piece. The analyses are not done with this, and so I want to be very careful not to report things that have not been fully vetted yet, but I want to give you a little snippet of excitement for what's to come. So, remember those actigraphs that I showed you? I showed you kind of 4 nights of sleep for each given child. Well, here's what we did in this given graph. We took all of the nights of data and we put them on top of each other, right? We put them on top of each other and then we said, is there an overall pattern between there? And I apologize, it's kind of a lighter blue here, so it's hard for you to see. But you can see for this child, we see a pattern of nice low levels of activity at night and then active during the day. Here we have that child who's showing that same pattern, lower during the day, but they go down for a nap in the afternoon on some of the days, but not all the days. Another child down and then nap during the day. Here's a child who's transitioning out of 2 naps. So some days they had 2 naps, some days they had 1. But again, you can just look at it and you can see they have comparable patterns. And then here we have a child who has a very different pattern, right? That you really cannot see this nice flow or alignment between that circadian process and that homeostatic process, that it really is demonstrating some misalignment for us. One of these children develops autism. I'm not going to tell you which one. You're going to have to come back and read the study, okay? All right. With that being said, much of the data some of the data that I presented for you today comes from UC Davis, where I had some amazing collaborators and mentors. I want to make sure that I acknowledge them here. And funding. research takes money and it takes time. And this research was supported by 4 different grants from the National Institutes of Health, in addition to the Purdue Autism Cluster, the Autism Research Foundation, and the Purdue Center for Families. And I would be amiss if I didn't highlight my amazing graduate students, Emily, Ashley, and Perlin. They're a force to be reckoned with. I hope you all get to interact with them at some point. And the students of this Sleep and Developmental Studies Laboratory, it really does take a team. It really does take a team. These are all undergraduates or graduate students who have worked in the Sleep and Developmental Studies Laboratory, and I couldn't even fit them all on the slide. So please know that it takes a mini army, and thank you. Not only were you engaged, but you stayed awake. Nicely done. Yes, ma'am. Oh, I think they want you to talk to the microphone so that people online can hear you. I know. Everybody wants to be projected, right?
The on your family studies,
Yeah.
the genders, since I'm a Midwesterner, I won't say sex, were reversed in order. Did gender have any influence on it?
So gender does have an influence on it. Let me go ahead and back up slides so I can give you some accurate information. The image that I showed was just to kind of randomly represent, but I can tell you that based on whether this child is male or female, that the recurrence risk is very different. So the recurrence risk for males is closer to 30 to 40%, where the recurrence risk for females was closer to 10 to 15%. Okay?
The percentage is higher for males than females in the first one, right?
Correct. There is this unequal gender distribution in autism that's been replicated a lot. Interestingly enough, it's always been 4-to-1. That's always been kind of the go-to number, but we're seeing a shift closer to 3-to-1. So, and that's because I think more girls are being identified. Yes, ma'am. Oh, sorry. We've got to get the mic up here.
I was just curious to know what we can do to be helpful
Oh, wow.
as the general public.
As the general public, helpful with sleep or helpful with the research?
Helpful with the research.
So you can do a couple of things. One, you can sign up for studies. We have a lot of active studies, and actually if you go to the Purdue Autism Cluster webpage, which I will get to here, if you go to the Purdue Autism Cluster webpage, there's a whole section on active studies. So if you want to contribute to the science, that is one place that you can do that. If you would like to contribute to the science in a monetary manner, you can also go there, and there's a Donate Now button. Yeah, and the other thing is just you're doing it. Like, you're actively engaged in learning and being a part of the research. So thank you. Yes.
I have a high-functioning autistic son.
Yeah.
Who always says he doesn't sleep, but from our perspective, he does fall asleep, but maybe, you know, as you talk about the rhythms and everything, so what can we do to maybe get him better sleep?
So I can go ahead and answer based on the tiny bit of information that I have on your son, and I want to caveat that that doesn't mean that this holds for all families. So it sounds like your son may be able to tell you like why he doesn't feel he got a good night's sleep, right? He could.
I say, how did you sleep? And he goes, oh, you know, it could have been better, it could have been worse. He's 10.
Ooh. So he's 10, and I'm going to bet he's fairly rule-bound, right? Like, rules make a lot of sense to him? Yes. So I would ask him very concrete things, like, do you think it took you more than 20 minutes to fall asleep?
And he would say, I'm not good at time.
He'd say, I'm not good at time. You'd be like, well, I'm going to track it for you. I'm going to track it for you. And you'd be like, you know what? You fell asleep faster than 20 minutes. Good for you. Because it sounds like it's like a perception of sleep, and you really want to identify, is it perception or is it an actual problem? And they'll be like, oh, you know what? I looked up the American Academy of Pediatrics that as long as you're getting 9 hours of sleep, that's enough. Let's see, you went to bed at 8 and you got up at 7. You did it. Good job, right? So that's kind of how to, and maybe he's not. And maybe you're like, no, I'm not good at time, but I could tell you the clock's at 11 before I quit looking at it, right?
He doesn't go to sleep fast, I know
Yeah, yeah. And so one thing the kind of one thing that has been very well documented in autism with sleep onset, if that is his difficulty, is melatonin. I wouldn't, in general, I don't recommend medications. I'm not a psychiatrist, but I have done a fair amount of work looking at melatonin. It only is influential and positive for onset difficulties. It's not for anything else. Some people think like, oh, I'm going to give it because they go to bed at a normal time and then they get up at 2 a.m. It hasn't demonstrated that it's beneficial there. And there's even this extended release melatonin now that talks about that they can, and the studies aren't there yet. So I wouldn't go so far to endorse that. But a small number of milligrams under the tongue, right at bedtime, sounds like he could do it, right? You got to hang out like for 30 seconds with it under your tongue. And, yeah. Okay. But I will leave that up to your discretion. Yes. Other questions? Thank you.